Look at your hands. Turn them over. See the lines, the creases, the history etched into the skin. Press your fingertips together. Feel that? That sensation of pressure, of solid meeting solid. It is one of the first and most fundamental truths you have ever known. The world is solid. You are solid. You can touch things. You can hold them. You can press against the unyielding reality of the world and feel it press back. This is a truth upon which you have built your entire life. And it is a lie. A beautiful, elaborate, and necessary lie. But a lie nonetheless. You have never truly touched anything in your entire life. You have never felt the press of your own skin against itself. You have never held the hand of a loved one, not in the way you think you have. You have never caressed a face, or leaned against a wall, or felt the ground beneath your feet. Not once. Every sensation of contact you have ever experienced, every moment of perceived solidity, has been an illusion. An intricate ghost story told by your nerves to your brain. A phantom of connection in a universe defined by an unbridgeable distance. What you call touch is not contact. It is refusal. It is the story of two things approaching, coming impossibly close, yet always being held apart by an invisible, unyielding force. A force that screams, no, at the very edge of existence. This isn't poetry, not yet. This is physics. This is the bedrock of the material world. The distance that separates your fingertips right now, pressed together as they are, is as profound and absolute as the distance between stars. It is a gulf measured in the language of atoms, but it is a gulf nonetheless. And so, we begin with a question that threatens to unravel everything you take for granted. If you have never touched another person, what is a hug? If you have never felt the ground, what does it mean to stand? If all is separation, then what is connection? What is it that you're truly feeling when you think you're touching the world? To find the answer, we must journey down past the skin, past the cells, past the molecules. We must travel into the vast, echoing emptiness that makes up almost all of what you call you. We must go to a place where the rules of our world dissolve into whispers and probabilities. We must confront the ghost in the machine. The ghost that you are. The illusion begins with a simple, comfortable idea, the idea of substance. You see a chair, and you perceive it as a solid, continuous object. You trust that it will hold your weight. You see your own body as a complete, contained vessel. These are not unreasonable assumptions. They are survival mechanisms, mental shortcuts gifted to you by millennia of evolution. Without them, navigating the world would be impossible. But these shortcuts obscure a far stranger and more beautiful truth. The first layer of this illusion peels away when you consider what you are actually made of. You remember the diagrams from school. Everything is made of atoms. You, the air you breathe, the chair you sit on, the planet beneath you. All of it is a dance of these impossibly tiny constituents. This is where the lie of solidity first begins to fray. For an atom is not a tiny, hard marble. It is not a solid billiard ball. The most common and enduring image of an atom, a little solar system with a dense nucleus for a sun and neat little electrons for planets, is itself a convenient fiction. Reality is far more ethereal. An atom is, by any human standard, almost entirely empty space. Imagine an atom scaled up to the size of a vast cathedral. The nucleus, containing almost all of its mass, will be no larger than a single grain of sand suspended in the very center. The rest of that immense, echoing space, all of it, will be the domain of a few electrons. And even these are not solid points. They are more like wisps of smoke, clouds of probability, smeared out presences that are nowhere and everywhere at once. You're not made of solid stuff. You are made of emptiness. You are a constellation of countless trillions of these tiny, empty cathedrals. The space between the grain of sand nucleus and its ghostly electron shell is vast and vacant. And the space between each of your atoms is vaster still. You are a walking, talking, thinking collection of empty spaces. A human-shaped void. When you press your hand against a wooden table, you're bringing one collection of empty spaces into the vicinity of another, one ghost brushing against another. The idea that these two things, these two near-nothings, could ever truly touch in a way that means they're solid parts colliding becomes, at this scale, utterly absurd. If they were to truly meet, nucleus to nucleus, the result would not be touch. It will be nuclear fusion. It will be a star. So what is happening? What creates that sensation of unyielding, solid reality? What you feel is not matter. You're feeling force. As the outer edges of your atoms, those hazy, probabilistic clouds of electrons, approach the electron clouds of the table's atoms, a powerful conversation begins. Electrons carry a negative charge, and as the ancient law of electromagnetism dictates, like charges repel. It is a cosmic law of personal space. This repulsion, this invisible barrier of force, grows exponentially stronger as the atoms get closer. It is like trying to push the north poles of two powerful magnets together. You can feel the resistance build in the empty space between them. You can feel the field. That is touch. You are feeling the field. Your nerves, themselves made of atoms, register this immense electromagnetic pushback. They translate this silent, invisible war of forces into a signal, a stream of electrical information that travels up your arm to your brain. In your brain, the master storyteller, the magnificent weaver of illusions, receives this message that says repulsion and translates it into a much simpler, more useful story. It tells you a story called solid. It creates a feeling called pressure. It invents an experience called touch. You are not touching the table. You are hovering above it, suspended on an invisible cushion of electromagnetic force, a fraction of a nanometer away. Your body, your entire life, is a story of levitation. This deconstruction is not a modern revelation. It is a truth that has been slowly, painstakingly uncovered over centuries of human curiosity. It is a journey into the heart of matter that began with a simple, revolutionary thought. Let us travel back in time to ancient Greece. Imagine the dust motes dancing in a shaft of sunlight. Imagine a mind watching them, a mind trying to look past the world of appearances, the world of gods and myths, and ask a more fundamental question. What is the world made of? The philosopher Democritus, a man often described as laughing at the follies of the world, proposed a radical idea. He suggested that if you were to take any piece of matter, a stone, a leaf, a piece of bread, and cut it in half, and in half again, and again, and again, you would eventually reach a point where you could cut no further. You would arrive at a final, indivisible particle. He called this particle atomos, which means uncuttable. This was not science as we know it. It was a philosophical leap, an act of pure reason. There was no evidence, no experiment. It was an attempt to impose order on a chaotic world. For 2,000 years, this idea of the atom remained just that, an idea. A ghost in the philosophical machine, overshadowed by the more palatable theories of Aristotle, who believed matter was a continuous blend of elements like earth, air, fire, and water. The world, to the pre-scientific mind, was exactly what it appeared to be, solid, continuous, and whole. It was not until the early 19th century that the atom was resurrected, not by a philosopher, but by a quiet, meticulous Quaker schoolteacher in England named John Dalton. Dalton was obsessed with the weather, with the way gases mixed and behaved. He noticed that they seemed to combine in fixed, whole-number ratios, as if they were made of discrete packets of tiny, individual units. He dusted off the ancient Greek concept. He gave the atom weight and properties. He envisioned them as tiny, solid, indestructible spheres. The world, for Dalton, was like a vast collection of microscopic billiard balls, all obeying neat, predictable laws. This was a monumental step. It transformed the atom from a philosophical speculation into a scientific theory. But it preserved the essential illusion. Matter was still solid, just on a smaller scale. Dalton's atom was a hard little nugget of reality. The lie of solidity had simply been miniaturized. The first crack in this solid picture came at the close of the 19th century. In laboratories across Europe, physicists were experimenting with cathode ray tubes, glass chambers with the air pumped out, through which they passed electrical currents. They saw strange glows, mysterious rays. In Cambridge, a physicist named Joseph John Thomson conducted a series of ingenious experiments. He showed that these rays were not light, but were in fact composed of particles. And these particles were bizarre. They were incredibly tiny, far smaller than any known atom, and they carried a negative electrical charge. He had discovered the electron. This changed everything. The atom was not atomos, after all. It was not uncuttable. It had parts. Thomson imagined the atom as a sort of plum pudding, a sphere of positive charge with these negative electrons dotted throughout it, like raisins in a dessert. The atom was still solid, in this view, but it was now a composite object. It was divisible, and it contained the very seed of the force that would later explain touch, electricity. The little negative charges were the key. The true shock, the moment that vaporized the idea of solid atom forever, came a few years later in 1909. It came from a man who was Thomson's own student, a boisterous, straight-talking New Zealander named Ernest Rutherford. Rutherford was a scientist who trusted experiment above all else. He distrusted elegant theories that were not backed by hard data. He decided to test his old mentor's plum pudding model. He designed what seems, in retrospect, a beautifully simple experiment. He would shoot things at an atom and see what happened. The bullets he chose were alpha particles, small, positively charged particles emitted by radioactive materials. The target was an exquisitely thin sheet of gold foil, so thin it was almost translucent, only a few hundred atoms thick. He set up a detector screen around the foil to catch the alpha particles after they passed through. The expectation was clear. If atoms were soft, spongy, plum puddings of matter, the tiny, fast-moving alpha particles should zip right through the foil with barely a deflection. It would be like firing a cannonball through a piece of tissue paper. The experiment began. And for the most part, that is exactly what happened. Particle after particle flew straight through the gold foil, just as predicted. But then, something impossible occurred. Once in a while, about 1 in 8,000 times, an alpha particle would not go through. It would ricochet off at a sharp angle. Even more shockingly, some would bounce almost straight back, as if they had hit a solid wall. Rutherford was famously thunderstruck. He later said, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you." The plum pudding model was dead. There was no way a soft sphere of matter could repel a speeding alpha particle like that. Something inside the atom was incredibly small, incredibly dense, and positively charged. After months of calculation and thought, Rutherford pieced together the truth. The atom was not a pudding. It was, as we described earlier, a miniature solar system. A tiny, heavy, positively charged nucleus at the center with the light, negative electrons orbiting far, far away. Paragrafo e paragrafo. And in between, nothing. Vast, empty space. This was the birth of the nuclear atom, and it was the death of solidity. The reason most alpha particles passed through was because they were traveling through that emptiness. They were missing the nucleus entirely. But the 1 in 8,000 that happened to be on a direct collision course with that tiny, massive, positive nucleus was violently repelled by its powerful positive charge. Rutherford had not seen the nucleus. He had inferred its existence from the shadows it cast, from the way it pushed back. He had, in a sense, touched the atom with his alpha particles and discovered that it was mostly a ghost. The journey was not over. Rutherford's model had its own problems. Why didn't the negative electrons spiral into the positive nucleus, drawn by their opposing charges? It took another visionary, the Danish physicist Niels Bohr, a man who was as much a poet as a scientist, to solve this. Bohr introduced the strange new rules of quantum theory. He proposed that electrons could only exist in specific, allowed orbits like steps on a ladder. They could not exist in the space between. They could leap from one orbit to another, but they could never spiral. Why? The universe simply did not allow it. It was a fundamental rule of the new game. With each step, from Democritus's philosophical guess to Dalton's solid ball, to Thomson's pudding, to Rutherford's empty solar system, to Bohr's quantum ladder, our understanding became stranger. We journeyed deeper into the heart of matter, only to find that it was less and less material. We sought the ultimate substance of reality and found, instead, forces, fields, and rules written in a language of mathematics and probability. We discovered that the world you perceive, the hard, solid, reliable world, is a high-level summary of a reality that is almost entirely empty space, governed by invisible forces that hold everything tantalizingly, permanently apart. So let us dive deeper now into the mechanics of this grand illusion. Let us build the world back up from these strange, ghostly ingredients and see how the feeling of touch emerges from the principle of separation. First, we must become familiar with the cast of characters in this subatomic drama. At the heart of every atom, you have the nucleus. This is the seat of mass, the anchor of reality. It is built from two types of particles tightly bound together: the protons, which carry a positive electrical charge, and the neutrons, which have no charge at all. They are the stoic, heavy center around which everything else revolves. Then you have the electrons. These are the flighty, energetic, and ultimately more influential characters in our story of touch. They are thousands of times less massive than the particles in the nucleus, but they occupy a vast territory. They do not orbit in neat circles, as Bohr first imagined. The modern quantum picture is far stranger. An electron exists as a cloud of probability, a standing wave of potential. Imagine a blurry, vibrating haze surrounding the nucleus. This haze, called an orbital or an electron cloud, represents the region where the electron is most likely to be found if you were to look for it. But until you look, it is not in any single place. It is, in a very real sense, all places within that cloud at once. This cloud is the atom's face to the world. It is its outer boundary, its skin, and this skin is purely electrical. It is a field of negative charge. Now consider two atoms approaching each other. It doesn't matter what kind. A carbon atom in the skin of your finger and a carbon atom in the wood of a table. As they draw near, the first parts of them to interact are these outermost electron clouds, these soft, hazy veils of negative potential. And what do two negative charges do when they meet? They repel. This is one of the four fundamental forces of nature, the electromagnetic force. It is the force that governs light, electricity, and magnetism. And it is the force that governs all of chemistry and biology. It is the architect of the world you see. Think of this repulsion as an infinitely perfect, infinitely strong spring. As the atoms get closer, the spring compresses. The repulsive force builds at an incredible rate. To push them even a little bit closer requires an enormous amount of energy. To make them actually touch, to merge their electron clouds, would require the kind of energy found in the core of a star. So when you place your hand on the table, the atoms of your hand settle into an equilibrium distance from the atoms of the table. They are pushed down by the force of gravity and the weight of your arm, and they're pushed up by this immense electromagnetic repulsion. They find a balance point. They hover. The distance of this hover is infinitesimal, on the order of a few angstroms. But it is not zero. It can never be zero. The boundary is absolute. The strength of this force is difficult to overstate. It is what gives matter its apparent solidity. A wall feels solid not because its atoms are tightly packed, but because the collective electromagnetic repulsion of its trillions upon trillions of atoms creates an impenetrable wall of force. You are not hitting a wall of matter. You are hitting a wall of math, a wall of pure field. How do we know this? How can we be so sure of a reality that is so contrary to our senses? We know because we have learned to see without looking. We have devised experiments that act as extensions of our senses, allowing us to probe this unseen realm. Rutherford's gold foil experiment was a perfect example of this. He never saw a nucleus. He saw the effect of a nucleus. He saw its energetic signature, its repulsive shout echoing through his laboratory. He was like a person in a dark room who, by throwing tennis balls and listening to where they bounce, can map out the shape of the furniture. It is indirect evidence, but it is powerful. It is seeing the ripples on a pond and knowing a stone was thrown. Modern science has refined these techniques to an incredible degree. Particle accelerators are our modern equivalent of Rutherford's alpha particle gun. They are colossal machines, miles in circumference, that use powerful magnetic fields to accelerate particles like protons and electrons to near the speed of light. They then smash these particles into targets, or into each other. The collision is not a simple crash. It is a cataclysm of energy. In that fleeting moment of impact, the raw energy is so immense that, thanks to Einstein's famous equation, E equals mc squared, it can momentarily convert into matter. New, exotic, and unstable particles flash into existence for fractions of a second before decaying back into energy. Surrounding this point of collision are gargantuan, cathedral-sized detectors. These are not cameras. They are complex layers of sensors, each designed to catch the shrapnel from the explosion. They track the path, the energy, the charge of every particle that flies out. The result is not a picture, but a torrent of data. A list of coordinates, energies, and timings. From this data, physicists reconstruct the event. They work backwards, like cosmic detectives, from the evidence left behind to deduce what must have happened at the moment of impact. They see the telltale signature of a quark, the energetic fingerprint of a gluon, the decay pattern of a Higgs boson. They are reading the shadows on the cave wall. They are tracing the fingerprints left in the mathematical snow. They have never seen a quark in isolation. The rules of the universe seem to forbid it, but they have seen its undeniable effects a million times over. They know the electromagnetic force is real because they can manipulate it to steer particles, measure its precise strength, and predict its behavior with an accuracy unmatched by any other scientific theory. The evidence is overwhelming. The world is not solid. Touch is a force field. You are a ghost, held together by rules, interacting with other ghosts through fields of pure energy. And if that were the end of the story, it would be strange enough. But the reality is stranger still. Because when we talk about that electron cloud, that outer skin of the atom, we're not just talking about something small and empty. We're talking about something that fundamentally breaks the rules of our everyday logic. We must now amplify the paradox. We must descend from the relatively clear, if empty, world of Rutherford and into the truly bewildering fog of quantum mechanics. Niels Bohr's model of electrons on fixed ladder rungs was a brilliant stopgap, but raised more questions than it answered. Why were only certain orbits allowed? What happened when an electron jumped between them? Did it vanish from one spot and instantly reappear in another, without traveling through the space in between? This question gave birth to a new generation of physics in the 1920s, led by figures like Werner Heisenberg and Erwin Schrödinger. They proposed an idea that was, and still is, deeply disturbing to our intuition. The electron is not a particle. Not really. Nor is it a wave. Not really. It is somehow both, and neither. An electron, when you're not looking at it, does not have a definite position. It exists in a state of pure potential, a superposition of all its possible locations at once. Schrödinger described this with a complex mathematical tool called the wave function, which encoded not the position of the electron, but the probability of finding it at any given point. Think back to the electron cloud. It is not a cloud of stuff. It is a cloud of mathematical possibility. The electron is not in the cloud. The electron is the cloud. It is smeared out, a wave of existence, until something forces it to take a stand. What forces it to take a stand? Measurement, observation, interaction. The moment you try to touch the electron, whether with a photon of light or another particle, to find out where it is, its wave of possibility collapses. It instantly resolves into a single, definite point. The ghost suddenly materializes, but the very act of forcing it to materialize changes it forever. You learn its position, but you lose all information about its momentum. You can know where it is or where it is going, but never both at the same time. This is Heisenberg's famous uncertainty principle. This isn't a limitation of our instruments. It is not that our tools are too clumsy to measure both things at once. The universe itself insists that this information does not coexist. The reality of position is created by the act of measuring it. Now apply this to the idea of touch. When the electron cloud of your finger approaches the electron cloud of the table, what is actually happening? It is not a meeting of two definite surfaces. It is an interaction between two clouds of pure probability, two shimmering fields of potential. The repulsive force you feel is the result of these two wave functions overlapping and interfering with each other. And the act of feeling it, of your nerves registering that force, is an act of measurement. Your touch is collapsing wave functions. You are, by the very act of interacting with the world, forcing it to become definite. The table, at the quantum level, was a fuzzy, probabilistic thing until your probabilistic hand came near. Your interaction, your touch, forces the atoms on the surface of the table and the surface of your skin to choose a position. Reality solidifies under your fingertips, not because it was always solid, but because your presence demanded it. This is the measurement problem, one of the deepest and most unsettling mysteries in all of science. It places the observer, the interactor, in a very strange and central role. You are not a passive witness to a pre-existing reality. You are an active participant in the ongoing creation of the reality you experience. This violates our most cherished classical laws. The law of locality, which says that an object can only be affected by its immediate surroundings, seems to be challenged by quantum entanglement, where two particles can remain mysteriously linked, their states instantly mirroring each other across vast distances. Einstein famously called this spooky action at a distance. It violates our sense of objective reality, the idea that things have definite properties whether we are looking at them or not. Quantum mechanics says no. A particle does not have a position until it is measured. The moon, a physicist once provocatively joked, is not there when nobody looks. And it utterly demolishes our simple, intuitive notion of touch. Touch is not a meeting. It is a quantum negotiation. It is a constant, roiling process of potentiality and actualization, of waves collapsing and reforming, of reality snapping into focus because you are there to feel it. This brings us to the precipice of a philosophical abyss. If the fundamental building blocks of your body are these ghostly, probabilistic entities, then what are you? Let us make this personal. Let us bridge the gap from the world of particles to the world of people. You are built from these quantum ghosts. Every single atom in your body, the carbon in your DNA, the iron in your blood, the calcium in your bones, is a collection of these probabilistic clouds. You are, in the most literal sense, composed of uncertainty. You are a walking, talking, thinking wave function of staggering complexity. You are a 70-kilogram cloud of probability. The feeling of being a single, solid, continuous self is an emergent property. It is a high-level phenomenon, like the wetness of water or the temperature of a gas. A single water molecule is not wet. A single atom does not have a temperature. These properties emerge from the collective behavior of trillions of individuals. In the same way, your feeling of solidity and selfhood emerges from the quantum dance of the countless particles that constitute you. You are a stable pattern, a self-sustaining resonance in the quantum foam, a temporary, intricate knot in the fabric of space-time. So what does it mean to be real? If the fundamental constituents of reality do not have fixed properties, if they flicker in and out of existence, if they're governed by probability and not certainty, then our entire concept of real needs to be reevaluated. The table feels real because it reliably resists you. Your body feels real because you have a consistent internal experience of it. But this reality is a relational one. It is defined by interaction. The table is real to you because you can interact with it. Your hand is real to the table because it provides a force that must be countered. Reality is not a static state of being. It is an active process, a verb, not a noun. And this brings us back to that most intimate of interactions, the touch of another human being. When you hold someone's hand, what is actually happening? The electron clouds of the atoms in your skin are repelling the electron clouds of the atoms in their skin. An invisible, unbridgeable gap of pure force separates you. You're not making physical contact. Not a single atom of your body is touching a single atom of theirs. You are feeling the ghost of their hand, and they are feeling the ghost of yours. The warmth you feel is not the direct transfer of heat by contact. It is the radiation of infrared energy across that infinitesimal gap. Your atoms are jiggling faster than theirs, and they are emitting photons of light. These photons cross the void and are absorbed by the atoms in their skin, causing them to jiggle faster. Your brain interprets this increase in atomic jiggling as warmth. Every sensation is mediated. Every interaction is at a distance. You are fundamentally, physically, alone in your own collection of atoms. A self-contained island universe of force and matter. Is this a terrifying thought? A proclamation of ultimate loneliness? Perhaps. Or perhaps it is an invitation to redefine what connection truly means. If connection is not the collision of matter, then it must be something else. What if the entire experience of touch, of solidity, of the world itself, is a product of consciousness? This is a speculative leap, a step beyond the boundaries of established science and into the realm of philosophical inquiry. But it is a leap that the strangeness of quantum mechanics almost seems to demand. Consider this. The raw data your body receives is just force, repulsion, an increase in the kinetic energy of atoms. It is a stream of sterile, impersonal information. It is your brain, your consciousness, that transforms this data into the rich, nuanced tapestry of experience. It takes the signal of electromagnetic repulsion and paints a picture of a lover's caress. It takes the data of infrared radiation and creates the feeling of warmth and comfort. It takes the vibrations of air molecules and constructs the sound of a reassuring voice. Your mind is the artist that gives meaning to the sterile physics of the universe. The world is not out there, complete and fully formed. The world is a co-creation between the raw potential of the quantum realm and the interpretive power of your conscious mind. The feeling of connection you experience when you hold someone's hand is not in the physics. The physics is just repulsion. The connection is in the meaning your mind assigns to that act. It is an act of recognition, of presence, of shared intent. You are recognizing that the pattern of atoms across the gap from you, the pattern called another person, is like your own pattern. You are sharing a moment in which your two separate, isolated fields of being are brought into a deliberate, meaningful alignment. The beauty of a hug is not that your matter is merging with their matter. The beauty is that despite the absolute, unbreachable physical separation, you can choose to bring your fields of force close to one another. You can choose to share warmth. You can choose to create a shared space of safety and recognition. The connection is not physical. It is emotional. It is psychological. It is perhaps informational. This understanding does not diminish the experience. It elevates it. It makes it more miraculous. A hug is no longer a simple act of pressing two bodies together. It is an act of profound defiance against the inherent separateness of the universe. It is a testament to the power of consciousness to create meaning and intimacy where physics only offers distance. We have journeyed far. From a simple question about touch, we have dismantled the solid world, traveled through the history of a revolutionary idea, and stared into the strange, probabilistic heart of matter itself. We have found that you are made of emptiness, that you are governed by forces, and that your reality is shaped by your own interaction with it. So, let us return, finally, to our central question. Have you ever truly touched another human being? The answer we now see is a beautiful and profound paradox. Physically? No, never. You are forever encased in your own shell of electromagnetic force, hovering a quantum breath away from everything else in the universe. The laws of physics have built an invisible wall around every atom of your being, a wall that has never been breached. You are an island. But does that mean you have never known connection? Of course not. It means that connection is a far more mysterious and magical phenomenon than you ever imagined. Connection is not about the crude mashing of matter. It is about resonance. It is about the alignment of two complex patterns. It is the ghost of your hand recognizing the ghost of another, and the conscious minds that pilot these ghostly vessels choosing to share a moment of mutual recognition. The final metaphor, then, is not one of contact, but of music. Think of two violins. They can be locked in separate glass cases, unable to touch. Yet if you play a perfect A on one violin, the A string on the other violin across the room will begin to vibrate in sympathy. It will begin to hum with the same frequency. This is called sympathetic resonance. They have not touched, but they are connected. They are sharing a state. They are communicating on a level of pure form, of pure vibration. This is the nature of human connection in a universe of separation. Your consciousness is a complex vibration. Another person's consciousness is another. When you experience love, empathy, or understanding, it is not because your atoms have met. It is because your two patterns have achieved a state of resonance. You are vibrating in sympathy with each other. You are feeling their music, and they're feeling yours. The physical act of touch, of bringing your force fields close together, is merely one way to tune the instruments. It is a powerful way to initiate that resonance. But the connection itself happens on a higher, more abstract plane. It is a connection of mind to mind, of pattern to pattern, of soul to soul. So do not mourn the loss of a solid world. Do not feel lonely in your fortress of force. Instead, feel the wonder. The universe is not a collection of dumb, solid objects. It is a shimmering, interconnected web of potential and information. And you are not just a piece of it. You are a conscious node within that web, capable of collapsing possibility into experience, of translating sterile force into profound feeling, of creating meaning and connection out of thin air. The distance between you and the rest of the world is not a bug. It is a feature. It is the necessary canvas upon which the art of consciousness can be painted. It is the silence that makes the music possible. Look at your hands again. Press your fingertips together. Feel that sensation. It is not solidity. It is not contact. It is the song of the universe, reminding you that you are here. And it is the echo of another song, just across the void, listening back.